Good morning, students. I hope you all are doing good. Yesterday's video, you have gone through comparison of EMF of two cells with a potentiometer and about the potentiometer. Today we are going to discuss a new topic which is measurement of internal resistance of a cell by potentiometer. This is one of the very important 5-mark question from this unit. So you can mark and study. It is a very important question, a 5-mark question from second unit. Let us see. Yesterday you have gone through the video potentiometer, and here also you can see the same structure of potentiometer arrangement. Here just in this potentiometer, one cell with EMF is connected. Here you can see one cell of EMF epsilon is connected and this one internal resistance is finding by using this potentiometer wire. Potentiometer, I said yesterday, 10 lines 100 meter wire will be there. There only we are finding the balancing length, and that balancing length is equal to the what potential difference in the cell. So that is what yesterday we have seen, and here also you can see the circuit diagram to measure this internal resistance. How the circuit is connected, you can see this. You see, from C the positive terminal of battery is connected, and from this D through a key negative terminal of the battery is connected, and this is what we can tell it is forming as a primary circuit. Yesterday also I told this is primary circuit, and secondary circuit means you can see that here 10 wire will be there, like this 1 meter 10 parallel rows wire will be there. Then whatever this cell, one cell is connected from the point C. The positive terminal of the cell, that is what the positive terminal of cell whose EMF epsilon, which is connected at the same side of the C, and this one internal resistance has to be determined. We need to find out the internal resistance of this cell. For that we are connecting the negative terminal of this cell is with a jockey through a galvanometer and a high resistance box. Another connection you can see from the same positive terminal, what is connected? A resistance box. This is what a resistance box. A resistance box is connected, and key along with the key K2 across this cell. This is the connection across. You can tell this is a parallel connection, and across the cell means parallel connection. You can tell. You see this EMF, this cell whose EMF is epsilon, and across this cell there is a resistance with a key K2 is connected. That is what the connections made. Now we know that experimental, how the experiment means. First thing is this key 2 is open. You know that key 2 open means off state. Open means off, closed means on state. Now the key to K2 is open. K2 open means this resistance is now not using. So what you can tell means now we are finding the balancing length Cj. So now we are finding the balancing length Cj is equal to L1, and now what is the balancing length? We know that the balancing length means the potential difference is equal to the current equal to the EMF through this wire. So that we will get the balancing length, isn't it? So that balancing length L1 is for the potential difference So EMF, we can tell we got the balancing length L1, and this balancing length L1 is directly proportional to this EMF. So EMF is directly proportional to L1. That is what the first thing. And we know that while changing this proportionality symbol is equal to IR L1, we can write down. This is equation 1. And you know what is this I? This is a current passing through this wire, potentiometer wire, and R means we know resistance per unit length. Per unit length resistance. That is what we have wrote here. Now the second thing is, what is happening means, you see this key is closed. Now the key is closed and this resistance box which is keeping some resistance, we can say that some 10 ohm resistor is kept on this resistance box, and this key 2 is closed. Now R be the internal resistance of this cell and this R be the external resistance. Small r be the internal resistance of the cell, capital R means the external resistance of the cell. Now current passing through this cell and the resistance R. So current passing through the cell, we can find I is equal to, we know that V by R formula. And here V is potential difference. So here the V is EMF. This one cell EMF only. So EMF I am writing. Now the resistance, we know that in this cell some internal resistance R is there. And along with that external resistance capital R is there. So that we can write R plus R. Okay. So this you can take equation 2. Now by using this we can find out the potential difference across this R. So that V is equal to, we know that formula V is equal to IR. So I value we know epsilon by R plus R. So what we can do is this, you can take equation 3. Now substitute 2 in 3. Substitute equation 2 in 3. So that what we will get V is equal to, instead of I, epsilon by R plus R. And that R also you have to write. So instead of only I am writing epsilon by R plus R. So this is what equation 4. Now the thing is, this potential difference is used to balance the potentiometer wire. Now this potentiometer wire is used to balance, to find the balancing length L2. So epsilon R by R plus R balancing length, this much potential difference is used to find the balancing length L2. This is what next equation. Now from this you can write epsilon R by R plus R is equal to, we know that IR proportionality we are changing L2. The I means current through the wire, R means resistance per unit length. This is equation 5. Okay. So this is what equation. Now what you can do means, here you can see this is equation 5, epsilon R by R plus R is equal to what IR into L2. Here you can see epsilon is equal to IR into L1. We know that how we got this equation. You see, the first thing we have did is what about this what here we have after the circuit connection, this key 2 is opened. So key 2 open means it is off state. So this resistance won't take only this EMF is there. So this EMF is what so the balancing length we are finding, Cj is equal to L1 we are measuring by opening this what key 2. So the EMF is epsilon, so that epsilon is directly proportional to L1, and we are changing the proportionality symbol. Epsilon is equal to, we are writing IR L1. IR means we know, I means the current passing through this wire, and R means what, the resistance per unit length. Next thing I said This is what first equation we found, and this is very important question, and we know that it is how we are finding the internal resistance. I will show you how. You see, then the second thing is now the key to is closed. Key to closed means now the resistance, external resistance R is active, along with this internal resistance of this cell also there. So that we are finding what the current passing through the cell and the resistance R. We know that, so that I is equal to V by R we are taking. So V means epsilon the EMF, and R means what this external resistance and the internal resistance, that is what R plus R. Now you can see that we are finding the potential across this R. So that we know the formula V is equal to I into R. So I means what epsilon by R plus R. So that we are substituting here. So we will get epsilon R by R plus R. Now this potential difference is what equal to the balancing length L2. So that potential difference is directly proportional to the L2. Now here we are changing IRL2 we got. Now what you have to do means this equation 5 and this equation 1 we have to divide. So from equation 1 and 5 divide both equations. So first equation is epsilon is equal to IRL1. Second equation we know, fifth equation epsilon R by R plus R. R plus R. Here what will come? Yeah, IRL2. So I cancel, RR cancel. Here epsilon cancel. So this R plus R will go upside. So R plus R divided by R equal to what will come? L1 by L2. Now this you split. So we can write R by R plus R divided by R equal to L1 by L2. Now R by R is 1. So you can cancel. Then 1 by 1 what we will get? 1 plus R by R equal to L1 by L2. Now take this one this side. So that R by R is equal to L1 by L2 we will get minus 1. So R is equal to this R you take it here, R into L1 by L2. Take the LCM here. Okay, next step we will do minus 1. So R is equal to R into, take the LCM here, L1 minus L2 by L2. Now we got a formula. R is equal to capital R into L1 minus L2 by L2. So R value, I said that we are giving by using the resistance box. So this is a non-value. L1 we are finding, L2 we are finding. If we are substituting all these, we will get the internal resistance of the cell. So this is what the derivation. Again I will show you the derivation once more. So first thing, first equation is EMF is directly proportional to L1. It is very important question. So that's what again I am doing. Epsilon is directly proportional to L1. This is equation, no need one. Next you change the proportionality. So I R L1. So this is, you can take 1, equation 1. Now take the second equation. For that we are finding current. I is equal to V by R formula. So V means epsilon and R means R plus R. So that we got I. This is equation 2. Now we are finding voltage PD across R. So V is equal to IR formula. I means I means this one. So epsilon by r plus r into what? R. That's what I wrote. Epsilon r by r plus r. Okay, this is equation 3. Now we got the potential difference, and this potential difference is used to find the balancing length L2. So epsilon r by r plus r is directly proportional to L2. This is what next equation. So this equation we can write epsilon r by r plus r equal to IR L2. This is equation 4. Now you can do this and this equation and this equation, just divide it. So from equation 4 and 1, so epsilon r by r plus r, capital R, small r, equal to IR L1 by IR L2. I cancel, R cancel, epsilon cancel. Now this r plus r will go upside, so that r plus r by r equal to L1 by L2. Now you split and write r by r plus r by r equal to L1 by L2. R by r is 1, so 1 plus r by r equal to L1 by L2. Take this one this side. So r by r equal to L1 by L2 minus 1. Now take the LCM, so that what we will get? R by r equal to L1 minus L2 by L2. So you can find r is equal to, take cross multiplication, r into L1 minus L2 by L2. Now we go to the internal resistance R, so that easily, because these all values is known, resistance value, L1 value finding, L2 value finding, substitute and find the internal resistance of the cell. So you can take a screenshot of this and study this. So already I explained about the circuit connection and all. Again just I am revising. You know that what is the use of this? We are finding this potentiometer. We are using this potentiometer to determine the internal resistance of this cell. For that circuit connection is made. You see the end C of this potentiometer wire is connected with the positive terminal of the battery BT, and you can see that the negative terminal of the battery is connected to this end D through a key 1. Okay, and this is forming a primary circuit. Then what is happening means the positive terminal of the cell EMF. This is what the positive terminal of the cell of EMF epsilon, and it is connected also with the same side of the C, and this cell internal resistance we need to determine. For that the negative terminal is connected with a jockey through a galvanometer and a high resistance box. Also you can see that another resistance box R is connected across this cell with a key K2. Now the first thing is this key K2 is open and finding the balancing length, so that we will get epsilon is directly proportional to L1. And next thing is now it is closed. Closed means on, so that now finding the balancing length L2. For that this calculation already explained. You can go through that. And this is one of the very important question. So my dear students, once you are watching the video, take this in your notebook, physics notebook, and learn it. It is very simple. and don't hesitate to ask your doubt. You can ask me your doubt either in the interactive section, or you can call me and ask your doubt. And learn this question. It is one of the very important question. Thank you all. Bye bye.